talk about this. I got these problems from your book. Let's see if I can get my teeth right now. And I want you to honestly just gently scratch this out. Because I want you to not look at that function right now. Okay, so you need to learn how to read a function without actually plugging it in and chugging it out. You need to do both ways, obviously. But we need to read a function correctly from a graph, meaning the following. If I were to tell you, without looking at this, if I said, what's the f of -3, or estimate it for me, what am I actually going to go to, or what am I looking at on this lovely graph right here? So would you all agree that this is your x value, correct? Okay, so I'm asking you if when x is -3, so -3 would be 1, 2 right here, what is the y value? What would be your output y value, which would be on the graph right here, correct? So roughly, what do you think? What do you want to estimate that to be around? All right, so let's do this again. If I want you to find the f of 0.5. So you are going to x at 0.5 or 1/2, and you are going to tell me what the y value is on the function. So you kind of draw a line to the function. It kind of looks to me like we're at -1. All right, and now f of 0. Well, it looks like we've got two options. We could go up this way or down this way, but those arrows are actually never touching that axis. So anybody know what's going to happen here? Well, good try. It's actually, I'm pretty sure it's going to be undefined, okay? Now, how can you test this out for sure? Well, then you plug it into the function that they've given you. So if I said, what's the f of -3? Then I'd plug in -3 minus 1 over -3, which is -4 over -3, which is 1 1/3, 1.3 repeating. Very nice. F of 0.5, 0.5 minus 1 over 0.5, so -0.5 over 0.5, -1, which is right about what we got. And then f of 0, 0 minus 1 over 0, and there you go. You can't have 0 in the denominator. That is undefined. So you've got to now look at the graph and try to estimate yourself, okay? Look at the graph, see if you can actually tell on the graph what your y output would be. And then we're going to do this other kind of example here. They've done one like this also in tonight's homework. It says, the quantity of paper recycled in the United States in thousands of tons from 1993 to 2007 can be modeled by the function p of x equals negative, bada, 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 where x is the number of years since 93. Underline that. Number of years since 1993. So even though the graph is starting at 0, 0 represents what?
Years.
Of what year?
1990.
Thank you. Okay, so year 4 is actually 1997. Year 8 would be 8 years later. Does that make sense? Okay. So we are using the graph to estimate the amount of paper recycled in 1993, 99, and 2006. So again, 1993 is really f of what number? 0. So estimate for me. What do you think f of 0 is, roughly?
36.
Now, I put 36,000. 36, again, it's in thousands of tons, so I'm just going to put 36,000. You can write 36, and then you can write tons afterward, thousands of tons. 1999, how would you write that? F of what? 6 years after 93. So let's go up to the graph, and again, a little over 45,000. So 46,000, I'm going to say again. We're just estimating. There's no wrong or right. Just got to be near the answer. And 2006, how far is 2006 from 1993? F of 13 is roughly what? A little over 50,000, 51,000 maybe? Okay, 52, my bad, I'm sorry. You are then asked to find the value algebraically. How would you do that? Plug what in?
The number of years.
Okay, so you plug in, so if we want to find f of 0, you would actually plug it into this function right here. 0 would cancel, 0, 0, everything would cancel except this last number, 35.75, which is roughly 35,750. That's pretty much what we got. And that's what you would do, then find f of 6. I'm not going to do that. I'm going to assume you can algebraically plug it in, right? All right. But let's look at this. Use the graph to estimate the year in which the quantity of paper recycled reached 50,000. So now they're asking you backwards. They're saying, when am I going to reach 50,000? When does this, what year? So to me, it kind of looks like between year 12 and year 13. I mean, you could say 12 and a half if you want to. We're talking years though, so you could say anywhere between 2005 and 2006 is what I would estimate. How could you confirm it algebraically? You would plug in f of 12, you'd plug in f of 13, and you'd look to see when did it reach that 50,000 mark into that function they gave you. Is this hard though, really? I don't think it's hard, but I'll tell you, a lot of students struggle with visualizing where it is. But it's just looking at the graph on the x-axis to where it matches the y value and vice versa. All right, so that's the first part of tonight. I want us to talk about domain. When you're looking at domain visually, you're looking at the graph on the x-axis, because that's what domain is. We all know that. You're looking to see how wide is this graph getting? All the way from the left to all the way to the right, how wide is this picture getting? So domain is how wide is the graph? And you're on the x-axis. On the x-axis, you're looking at your x values for domain. Range then would be what? How what? Tall. Very good. I was waiting for deep. Deep and what? No? No one knows that song? Good churchgoers? His is. How tall is the graph? How tall is it getting? Is there any graph down here? Is there any graph up here? That would be on the y-axis. You look at your y outputs. Okay? So I'm going to draw two easy ones for you, and then we'll look at a third one. On the x-axis, how wide is this picture? If I can go like this, it looks like my picture is right there, correct? Width-wise. So there's nothing to the left of what number?
1.
Of 1. So my first x value should be 1. The arrow means what? Goes on and on forever to the right, correct? So you would write your domain, God bless you, would be from 1 to infinity. What is it? Bracket, parentheses, what is it? Which one's parentheses? 1 is bracket, parentheses is with the infinity. Good job. So that's how wide am I getting? Now, let's talk about the height of this picture. How tall is this picture getting? So when I go like this, it kind of looks like I'm leveling off right here. Agreed? A lot of people think that. But I want you to understand that arrows in mathematics, they creep up, okay? This right here, ever so slightly, is creeping up. You could still be able to plug in an x value of 100 and still get some y value out. Okay, so even though it looks like it's leveling off, it really isn't. So, but it is starting down here at the bottom on the y. Where is it starting on the y? 0. And then where is it going to? Positive infinity. Yes.
That had an asymptote.
Yes.
Would it still be positive infinity?
Not if it had an asymptote. So it would be 0 to infinity. So easy breezy right now. Let's talk about this second one. Again, start with domain. You try it for a minute, see if you can figure out domain and range. Let's see if you're right. How wide is my picture? How tall is my picture? So if I'm taking my Post-it notes, it looks like my picture's from here on the X to here, right? On the X-axis. What's that point on the X-axis? -4. What's this point on the X-axis? 1. Now, we got to talk about some brackets here and parentheses here. So I know I've got a picture from -4 to 1. Parentheses or brackets where? Correct. This one's open. I don't actually have, I'm getting very close to that value, but I don't actually have it. And then bracket at 1. Now, how tall is this picture? So again, if I'm trying to use my little sheets here, I'd be like that. Now, be careful. We're talking about the y-axis now. This is where everybody always gets confused because I'll have so many students tell me like 1. No, on the y-axis, what's this point on the y? 0. What's this point on the y?
-4.
Okay, so I'm at -4 and 0. Is it open or closed? Do I have any problems? Well, -4 would definitely be closed. What about 0? Because that's open. But over here, it's closed. So which one do you think it is? Closed or open?
Bracket.
It is bracket. As long as one is closed. So they're both bracket. All right, and then I'm going to do just one more for you. I'll give you a minute to kind of copy it down, and then we'll talk about this picture. So if, again, I don't know, maybe this doesn't look visually pleasing to you. To me, I feel like I understand it when I do my little sticky notes here. Okay, but if I try to start going widthwise, because it helps me actually look at the x-axis then, the picture looks like it starts right here, agreed? And then I still have picture, it looks like it stops here, but that arrow implies that it's going to go up and up and up and up and up, right? So wouldn't my Post-it note have to go out, 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 out? Okay. So it looks like I have everything covered from, what point is this? -6 to infinity? Okay, but I have a little problem in my domain right about here at a hole. We have problems at holes. Where is that problem on the x-axis located at? No, it doesn't look perfectly straight. But on the x-axis, it's located right here at -3. So from -6 to -3, I'm good. I got a pretty curved picture right there. So my domain would be totally fine from -6 bracket, because it's closed, to -3. But not exactly at -3, right? So I leave it open. So I have this beautiful picture, but wait, Mrs. Seth, there's more to the picture. I know. Let's keep going. There's more picture from here to here, agreed? How would I write that? United with -3 to positive infinity. That is your domain. When you see holes tonight, guys, or holes in the graph, you want to be careful there. You've got to take it then into sections, into pieces. All right. So let's talk about range-wise. Range-wise, it looks like I'm about here. And again, that arrow implies that I'm going to go all the way up, right? So it looks like my lowest value is -6 again. And it looks like I'm going all the way up to infinity. But Mrs. Seti, you just said be careful of holes. Yes, be careful of holes. So let's go up to that hole. I'm open here, but am I covered over here on this end of the picture? I am. I'm okay, actually. I have whatever X value is open here and Y value, it's actually closed over here on the y-axis. On the y-axis. Remember, we're talking about y-axis. So my lowest value for y would be -6. My highest value for y, this is okay. We've already closed it over here. We already have that point. And then it goes on and on and on, up and up and up. So it would go all the way to positive infinity. That one is what we call a difficult one. I think what will happen is the more you do these, the more practice you get, the better you'll get at them.